Good morning to everyone. So today we are going to discuss about the problems related to thin cylinders. Okay, let us move on to the problem. Problems on thin cylinders. So problem one. So all are direct problem with respect to the formula substitution. Okay, the given data: a cylindrical pipe of diameter 1.5 meter and thickness 1.5 centimeters is subjected to an internal fluid pressure of 1.2 Newton per mm square. So determine first one, longitudinal stress. Longitudinal stress developed in the pipe. And second question is circumferential stress developed in the pipe. Okay. So let us write the given data. So pipe of external diameter capital D is equal to 1.5 meter and the thickness of pipe. So this is 1500 mm. Okay. And thickness of wall is equal to 1.5 centimeter. So which is nothing but 15 mm. Okay. So this T is equal to 15 mm and the external diameter is equal to 1500 mm. So then what about the D, small d, internal diameter? Okay. So D is equal to capital D minus 2 times of thickness. Okay. So which is nothing but 1500 minus 2 times of 15 mm. So it becomes 1470 mm. Okay. So what we need, fluid pressure, they have given that small p is equal to 1.2 Newton per mm square. Okay, now we have to calculate to find sigma 1, that is equal to circumferential stress or hoop stress. Sigma 2 is equal to longitudinal stress. Solution. So sigma 1, the formula is pressure into internal diameter divided by 2 times of thickness of wall. Okay, there is circumferential stress. Okay, now we are going to substitute the formulas, that is 1.2 Newton per mm squared multiplied with D. So D is nothing but 1470 divided by 2 into thickness of wall, that is 15 mm. So 1.2 into 1470 divided by 2 to 15. So it becomes 58.8 Newton per mm square. Similarly, sigma 2 becomes P divided by D into 40. So it becomes half of sigma 1 divided by 2. Then 29.4 Newton per mm square. So this is the direct substitution. Okay. So here we have to check. And one more thing I mentioned, the cylindrical pipe of diameter they mentioned. So directly we can take this as small d value. Okay, even though. So if I am going to consider like that, then the value will change. So okay, the value will be changed as P 1.2 into 1500 divided by 2 into thickness 15. So it becomes 60. So if I'm going to substitute D is equal to 1500 mm, then the answer becomes sigma 1 is equal to 60 Newton per mm square, and the sigma 2 is equal to 30 Newton per mm square. Okay. So we should move on to the next problem, that is problem 2. So a cylinder of a cylinder of internal diameter 2.5 meter and of thickness of thickness 5 centimeter contains a gas. If the tensile stress if the tensile stress in the material is not to exceed 80 Newton per mm squared, calculate the internal pressure of the gas. Internal pressure of the gas. So here the given data, okay, yeah, internal diameter. So D equal to 2.5 meter, that is 2500 mm. Okay, the thickness of wall is 5 centimeter. So T is equal to 5 centimeter, that is nothing but 50 mm. Okay, if the tensile stress of the material is not to exceed, so tensile stress of the stress is not to exceed 80 Newton per mm square, then calculate what is the pressure intensity. Okay, so we all know that if they have mentioned that the tensile stress, okay, now that is nothing but our hoop stress, that is the maximum stress. Okay, so now we are going to mention that tensile stress becomes sigma 1. So by using sigma 1 formula, okay, we can directly calculate the value of P. Okay, so solution. So circumferential stress sigma 1 is equal to P into D divided by 2T. Whereas P value we have to calculate. Sigma 1 they have given that 80 Newton per mm square into D. So dia is 2500 mm into thickness is nothing but 50 mm. Therefore, what is the value of P? Okay, so P and stress, pressure and stress both have same unit. Okay, Newton per mm square, no issue. So now the answer is 80 into 50. If I'm going to keep the P here, then 80 into 2 into 50 divided by 2500. it becomes pressure intensity P is equal to 3.2 Newton per mm square. Okay, so this is the formula related to tensile stress. So if the tensile stress is to be satisfied, then the pressure of the gas is 3.2 Newton per mm squared for the given container. Okay. Next, we should move on to the third problem. So, a cylinder of internal diameter, a cylinder of internal diameter 0.5 meter contains air at a pressure of 7 Newton per mm square. If the maximum permissible stress induced in the material is 80 Newton per mm square. Find the thickness of the cylinder. Find the thickness of the cylinder. So first we should go for the given data. Okay. So cylinder of internal diameter zero point 0.5 meter. So D is equal to 0.5 meter. So 500 mm is the internal diameter. So contains air at a pressure. So small p they have given as 7 Newton per mm square. Okay. The maximum permissible stress, okay, induced in the material. So permissible maximum permissible stress is equal to 80 Newton per mm square. Now the question is, what is the thickness of the cylinder? T is equal to what? So here the condition is uh, maximum permissible stress in the material. It denotes that the circumferential stress sigma 1. So that we are going to use the formula of sigma 1. Okay. So sigma 1 we know that. So circumferential stress sigma 1 is equal to 2p divided, sorry, PD divided by 2 times of thickness. So from this we have to calculate the thickness value. So sigma 1 we know that 80 Newton per mm squared, and P is nothing but 7 Newton per mm squared. D is equal to zero point 0.5, that is 500, then 2 into T. Therefore T becomes 7 into 500 divided by 2 into 8. So it becomes 21.875 mm. 21.875 mm. If that cylindrical material is to withstand that pressure 7 Newton per mm square, means the thickness of that cylinder is become 22 mm. Okay. So next, So likewise, we will see some one or two simple problem. Okay, now then after we will move on to the some another problems. Okay, next problem 4. So a thin cylinder of internal diameter 1.25 meter contains a fluid at an internal pressure of 2 Newton per mm square. Determine the determine the maximum thickness of the cylinder if first condition, the longitudinal stress, that is sigma 2, okay, is not exceed 30 Newton per mm square. And the second condition, the circumferential stress sigma 1 is not to exceed 45 Newton per mm square. So here we have to calculate the answer for sigma 1 and sigma 2. That is the thickness we have to calculate. Okay. From that, which one is having the maximum value, that we are going to use as that is adapt as a thickness. Okay. So let us move on to the problem. So given data. So internal diameter small d is equal to 1.25 meters, which is nothing but 1250 mm. So fluid internal pressure P is equal to 2 Newton per mm square. Okay. Sigma 2 value is 30 Newton per mm square and sigma 1 value is 45 Newton per mm square. Okay. Let us move on to the solution part. So first they are asking that the calculation of thickness. Okay. So with respect to sigma 1, what is the thickness? Similarly, with respect to sigma 2, what is the thickness? So by finding that which one is maximum now, that we are going to use as a thickness of that particular cylinder. So 45, pressure is 2 Newton per mm squared into D is 1250. Therefore, T becomes so 27.77 mm with respect to hoop stress. Next, with respect to longitudinal stress. It becomes 20.8 mm. Therefore, among them, which one have the maximum thickness? Therefore, the maximum thickness T is equal to 27.7 mm. Say T is equal to 28 mm to withstand the fluid pressure of 2 Newton per mm square. Okay, so this is the answer for our fourth question. Next one is fifth problem. A water main, that is pipe, okay, 80 centimeter diameter contains water at a pressure head of 100 meter. If the weight of water is 9810 Newton per meter cube, find the thickness. Find the thickness of the metal required for the water main. Required for the water main. Given the permissible stress as 20 Newton per mm square. Given the permissible stress as 20 Newton per mm square. Okay. First of all, we have to listen one thing. Here, so far, whatever the problem we have seen, that is, they have given the directly the pressure. Okay, but here they have given the water weight of the water and the pressure head. Okay, now, so from that, sorry, from pressure head. So from that, we have to calculate the water pressure first. Okay, so that one value only we have to use for the problems. Okay. So first of all, we should note down the given data. So water main of one, okay, here it is 80 centimeter. Okay, water main of 80 centimeter. So that D is equal to 80 centimeter, which is nothing but 800 mm. Okay, contains the water at a pressure head. So water pressure head H is equal to 100 meter. Okay, then weight of the water. Weight of the water. Okay, that is nothing but rho. So 9810. So here weight of the water, so rho into G. Okay, 9810 Newton per meter cube. Okay, so find the thickness of the metal and given the permissible stress. So here the permissible stress denotes that sigma 1 value is 20 Newton per mm square. Okay. Now let us find out the thickness. So solution part. So sigma 1 is equal to 20 Newton per mm square. So the value formula is P into D divided by 2T. So here we have to find out P value first. So pressure of water inside the main. Small p is equal to rho g h. So this is the formula. So rho g they have given as 9810 Newton per meter cube. H they have given as 100. Okay. So the answer becomes in Newton per meter square. So 9810 into 100. It becomes 981 into 10 to the power 3 Newton per meter square. Okay. Next, we should move on to the thing. That is, in terms of Newton per mm square, we have to change. Okay. So 981 into 10 to the power 3 divided by, so meter squared we have to convert in terms of mm. So 1000 square. Then it becomes 0. Pressure P is equal to 0.981 Newton per m square. Okay. Now we can substitute in this formula so that we can get the details of T. Therefore, sigma 1 is equal to 20 Newton per mm square into P 0.981 into D. So D they have given us 800 mm. So 800 mm divided by 2 into T. Therefore, T is equal to 0.981 multiplied with 800 divided by 2 times of 20. So it becomes 19.62 mm. So say thickness T is equal to 20 mm. So if I'm going to give 20 mm thickness, then the water main can withstand the pressure of the fluid, okay, inside the cylinder. Okay, so these are all some problems related to some basic problems related to thin cylinders. Okay, next we should move on to the efficiency of a joint. So efficiency of the joint. So we cannot directly cast like a single unit. Okay, now definitely we need to cast the connection. Okay, now which means a cylindrical part consists of one plate, so we have to roll down like a cylinder, and another plate we are going to cut it down as a circular cross section. So these things has to be fit as a single unit. Okay, so at the joint we are going to have some what it is, connections. Okay, now so based on the connections, the efficiency is going to, okay, either it may going to reduce or it may going to increase. Normally it is not a 100 percentage. Okay, now it may be reduced. Okay, so for that reduced value, how much it is going to withstand the pressure. Okay, now so that we are going to calculate. For that we are going to have calculate the efficiency. Okay, so efficiency of a joint. So the joints, there is the cylindrical shells. The cylindrical vessels or shells have two types of joints. Okay, in order to withstand their fluids inside. Okay, one is a longitudinal joint, longitudinal joint. Another one is circumferential joint. Okay, if possible, and is there any necessity to make the holes, then due to that holes also, uh, the area going to be given the resistance of the fluids, no fluid pressures, no, that will get reduced. Okay, so that also we have to ensure. Okay, So the efficiency of the, since I will tell, so this is one plate. Okay, so if I'm going to roll down this plate, I can make the section like this. Okay, so this section may have, at one place it have the one junction. Okay, so that is the joint. And similarly, uh, in another plate I'm going to cut down as a circular section. Okay, so this one I'm going to fit it here. Okay, so at the outermost edges it can have the joint. Okay, so this is nothing but longitudinal joint and circumferential joint. So because of that, and if there is any necessity to have a make the hole like a manhole or something, okay, if we are need to cast it, so because of that also the resistance area is going to reduce. Okay, so that's why the efficiency is going to decrease in the, due to the joint in the cylindrical shape. Okay, now, so the efficiency of the longitudinal and circumferential joint, longitudinal and circumferential joint are given by the formula related to stresses, related to corresponding stresses, as efficiency eta L and efficiency eta C. That is efficiency of a longitudinal joint, efficiency of the longitudinal joint, and efficiency of the circumferential joint. So with respect to the formula, sigma 1 is equal to P into D divided by 2T into. So how the way I'm going to cast here? So the one plate I'm going to rotate, roll down as a circular section so that the cylinder is going to mate. Okay, now, so here along the cross section the stress is going to act. Okay, so that the efficiency of longitudinal joint is to be comes under here. Okay, divided by eta L. Okay, similarly, longitudinal stress, with respect to longitudinal stress, sigma 2 is equal to P into D divided by 4 times of T into. So here the longitudinal section is acting here. Okay, so this is along the axis parallel to the longitudinal axis. So that NC efficiency of circumferential stress I am going to give here. So this is the formula which we are going to use to calculate the efficiency. So we have to note down the thing, that is the longitudinal joint, the circumferential stress is developed, whereas in circumferential joint the longitudinal stress is developed. Okay, now, so that's why the efficiency of longitudinal joint and the efficiency of circumferential joint has been placed vice versa. Okay, then efficiency of a joint means the efficiency of the longitudinal joint. Okay, so efficiency of the joint, if they have simply mentioned efficiency of the joint, means that the efficiency of the longitudinal joint, it denotes that the efficiency of the longitudinal joint, which is nothing but eta L. Okay, And if the efficiencies of a joint are given, the thickness of the thin shell is determined from equation uh, this one. Okay, sigma 1 is equal to P into D divided by 2T into eta L. Okay, efficiency. So if they have given efficiency value, efficiency of the joint is given, and if they are asking for thickness, then we have to go for the formula of sigma 1 is equal to P into D divided by 2T into eta L. Okay. So these are all the some constraints we can have in the efficiency of the joint. Thank you.